Hello everyone, welcome to Festive Tech Calendar 2024. My name is Deepthi Goguri. Today I'm going to talk about the query store advancements in SQL Server 2022. So at the beginning of this session today, we are going to discuss what are the advancements that happened from the SQL Server 2016 to 2019 related to the query store. So query store feature has been released in SQL Server 2016. If you are not familiar with this feature, this feature comes with the SQL Server itself. It is an inbuilt feature and it got introduced in SQL Server 2016. And the name of the feature is Query Store. So once you enable the query store, and this is a database level feature and not the server level feature, you have it available so that you can enable on the specific databases where you would like to collect the information about your queries. So what will happen once you enable the query store on your database? Once you enable it, it will go ahead and start collecting the queries, the query text, query plans, as well as the runtime metrics related to your queries along with the execution plans. So it will collect all of them over time, and you can set up in the configuration when you would like to um, clean up the collected data based upon the least used plans, as well as the queries will be cleaned up. So all of that is based upon the configuration settings. You can do that. So uh, it is very beneficial to enable this feature on the database because it is just like your monitoring tool, but it is not a third-party monitoring tool, but it is a SQL Server monitoring tool, which is also known as the flight data recorder, where it will collect all of your query plans, query text, and all of this execution plan information over time so that you can go ahead and look back and see what your queries were executing like, and if there is a performance issue you can just go ahead and look at the history of how your execution plans look like back, as well as what is the execution plan currently look like, and you can make the decisions on the top on based upon those um, metrics that it shows in the query store. So as this feature got introduced in SQL Server 2016, there were several advancements that were made all the way from the 2016 to 2022, which we are going to see as an overview in this slide. So in SQL Server 2016, they just introduced the query store feature. So it just uh, it just collected the query text, query plans, runtime metrics, execution plan information, as well as you have the graphical user interface reports where you can see all of the collected data by using the graphical user interface reports. Like for example, the most resource consuming queries and those sort of reports. You have 4 to 5 reports. I will show you in the demo. And the most advantage at the SQL Server 2016 query store is plan forcing. So whenever you know that a particular plan is working fine and it is working fine than the previous execution plan, or if the previous execution plan was working fine than the current execution plan, but you want that good enough plan to be forced. You do not have that availability before SQL Server 2016, but in SQL Server 2016, you can go ahead and force that good plan. Manually, you can force that plan so that the next time any any parameter is used within that query by, for example, the store procedure, the store procedure will always force this forced plan. So that is in SQL Server 2016. In SQL Server 2019, they made the advancement of automatic plan correction. So in SQL Server 2016, we have the plan forcing, which you do it manually. You force a plan so that next time the store procedure runs, it will use that force plan. But as an advancement in SQL Server 2016, and In the enterprise edition only, automatic plan correction is available where the SQL Server will automatically analyze your execution plans and it will make sure it always force the last good plan so that you do not have to manually intervene to force the good plan by yourself. And the other advancement in SQL Server 2017 is per plan weight stats. You can see the weight stats information per plan basis. In SQL Server 2016, the weight stats information was not included. In SQL Server 2019, they improved the perform like they increased the advancement of this feature um, by giving the availability to capture the custom policies. So until now we do not have the availability to set up our own policies like based upon the threshold values like the CPU threshold limit and how many times the query can run to capture that information. But with the custom capture policies, you can decide how your queries are going to be captured, like how many times your query have to be run and what threshold the CPU have to hit so that it will be get captured inside the query store. And also they included the plan forcing for the cursors as well in SQL Server 2019. So this is how it went, how the query store has been evolved from SQL Server 2016 to 2019. But let's go ahead and see what are the advancements in SQL Server 2022. In SQL Server 2022, the query store is enabled by default on any new databases that you create on SQL Server 2022. But if you are migrating the old versions of SQL Server database to the newer versions of SQL Server, and if you have the query store enabled on the older versions of SQL Server, it will keep the same. But if you do not have the query store on old SQL Server and you've migrated the database, you need to manually go ahead and enable the query store on that database. It won't by default enable on that migrated database. The other advancements is query store hints. So when you talk about the query store hints, this is just like the this is just like the query hints that you used to use. But the thing is, you might be having several parameter sensitive problem and parameter sniffing issue where you most of your parameters for your stored procedures created one gives one amount of like one amount of output, but there are here and there some parameters which are like outliers, which will create an entirely new execution plan where they have to scan the entire table and you have those parameter sensitive problem. And when you create a store procedure and the first time that you um, that you that you run the store procedure with a parameter sensitive one, it will generate an execution plan based upon that parameter and save it in the plan cache. And the next time, no matter what parameter you use, it will go and grab the execution plan from the plan cache. So that might be an issue if the next used parameter value only produces a couple of records. You do not have to scan the entire table based upon the previous execution plan, right? So that is a parameter sensitive problem. And by using the query store hints, you can solve a couple of solve the parameter sniffing problem, not only not only by regenerating the execution plan based upon the parameter values, but there are several other hints that you can use. You do not have to touch the code, but you can use the query store hints, which are specially designed by using the query um, store procedures for these hints. You can use that query store hint store procedures to enforce those hints without even touching the underneath code. We are going to see that in our demo, right? And the next advancement is query store on read-only replicas. Until SQL Server 2022, before SQL Server 2022, we do not have that option where query store data will not be captured on the read-only replicas, but this feature is available in the preview mode in SQL Server 2022. It is not yet in the public, but it is in the still in the preview mode. But the query store data can be captured on the read-only replicas as well. And the other advancement in SQL Server 2022 is the IQP features will use the feedback store within the query store to get the information from the query store data. And these IQP features that you are seeing here will use the query store to get the feedback information, collected feedback information. The degree of parallelism feedback, cardinality estimate feedback, and parallelism um, parameter sensitive plan optimization. IQP feature will be using the query store. So I'm going to talk about the query store hints in our demo as well as the PSP optimization, especially in this session to show you how these two features and advancement will work. So how does the query store on the read-only replicas work? Because you know that the secondary replicas are always read-only, and how do the query store data will be captured on that read-only replica, right? The modifications and the configurations are always made upon the primary read-write replica only. Even though you wanted to capture the information on the read-only secondary, you are always going to execute that query to enable the query store on the read-only replicas. That setting you will be setting that on the primary read-write only, because you know that read-only secondaries are always read-only. You can't make any changes to the read-only copies, right? But what is the mechanism? How does this actually work? Once you enable the um, query store to be collected on the read-only replicas, the changes are made on the read-write replica, but the data that is being captured on the read-only secondary, it will collect the information on the read-only secondaries queries, and then it will send the data back to the primary read-write replica using the same channel that the data it sends from the primary to the secondary using the always on availability group. It will use the same exact channel to send back the data from the read-only secondary to the primary read-write replica. That happens with every read-only secondary that you enable to collect the query store data. So uh, as I mentioned earlier, that query store on the read-only replicas um, is only in the preview mode. To enable that, you need to enable the trace flag 12606. And also, this isn't available for the use in production environments. It is only for the development environments. And once you collect the data, you can actually query the data visible by the role type, or by the secondary name. You can actually grab the data that is being collected and you run that information to collect that information, right, by using the query store views. So let's see the demo on how the query store hints actually work. So here I'm using the Azure SQL database, and we are using the AdventureWorks database here. So as I mentioned before we have, like, if you're not using the query store hints, if you do not have a query store enabled on the database, and if you are not in the SQL Server 2022, how do we actually resolve the problem if you want to use any hints? If you want to use any query hints, this is how you used. You actually modify the query itself and you use the option and use any of the hints. Like if you want to recompile, you use it option recompile, or use any other hints. Like for example, query optimizer compatibility level, you are using 110, but you are actually modifying the query itself if you observe here. But if you are using the query store hints, then you do not have to modify the underneath code, but you can use the query store hint store procedure to make that happen. to enable the hint. And so we are going to create a little store procedure here. I'm dropping the store procedure if it actually exists, and then create the store procedure. All I'm doing here is selecting couple of the columns from this table where the product ID is product ID parameter value here. I'm going to create this on the database AdventureWorks and execute that. Though I'm running this demo on the Azure SQL database, this is the same exact demo that we can also use on the SQL Server 2022, because this feature is already enabled in the Azure SQL, and then they enabled it on the SQL Server on-prem. So I'm going to clear out the query store here, and then I'm going to also clear out the procedure cache here. So I have created the store procedure, and now I'm going to execute these two store procedures. This store procedure with two different parameters, the same store procedure, right? So I created the store procedure and I'm running this execution for the first time, right? After creating the store procedure. Now let me enable the execution plan on and execute it. So the query is running, and let's see the execution plan. Now, if you see the execution plan, currently it used clustered index scan here. But if you see the results on the first execution, it produced like 360,000 records, right? 361,000 records approximately. And the second one, if you see the results, it's only 385 records. So this is a parameter sensitive problem here. But the first time, as it executed with that particular parameter value, with this parameter value, which generated 360,000 records, the plan got generated and it got saved inside the plan cache. Now the second execution just produced 385 rows with this parameter value, but it still used the clustered index scan, which we do not want here with this only little number of records that we actually received, 365 records. So why does this happen? This is the normal behavior, right? This plan got created with that parameter value the first time we executed with that particular parameter value 870 is a very sensitive because it produced too many records, but most of my parameter values just produce couple of hundreds of records. But as I executed this with this parameter value for the first time after I generated after I created the execution, after I created store procedure, this plan got saved inside the plan cache, and now we don't want that to be reused because most of my parameter values will only produce couple of records. So how do I resolve that problem? If I do not have the query store, I would have used the recompile option, right? But by using this query store hints, what we can do is we can get the query ID for this particular query by using this query and filtering out on the query text itself. And I'm running this to grab the query ID value, which is 3, right? And now I'll go ahead and run this particular store procedure designed for the query store set hints, and the query ID which we got is 3. So I have to enable query ID 3, right? And then I use the values, parameter values, two parameter values here. One is query ID and the other one is value. What hint value you want to use? I want to use option recompile here. And if I enable that, right, by using the query ID 3, after executing that, and then rerunning these executions again to see how it works. Now the same executions again. This time it uses the clustered index scan, but the next time it used index seek and the keylookup this time. That means it clearly used the query store hints. And you can see whether it used the hints by going into the properties. And you can see that it used the hint value, the query store statement hint, option recompile. It has been used. Now let's go ahead and see in the query store. Once we refresh, we have the query store, and we can see the top resource consuming queries here. This is the exact graphical user um, interface reports that we actually have by default, where you can take the advantage of seeing these reports. But this is in the graph model where I need to hover my mouse and see the query. But I would like to see it in the list format, right? So I can click on this little icon, view top resource consuming queries in grid format, so that it will give me the list of the query ID. And if you can see, there are two execution plans that got created for this one query that we executed, the store procedure. But if you see, if you hover your mouse, you are seeing it in the parameterized format, and you don't see the parameter value here that you use. But you see the two different execution plans that got created for those two parameter values. Now, um, now as we use the hint, right? We have used the hint and it produced a new execution plan here. Now, to see what all hints are enabled on my database, I can just run this query. Now, if you see the query hint ID is 4 and the query ID is 3, and then what hint was applied. But if you observe here, it shows the query hint ID 4. What about the query hint ID 1, 2, and 3 that I used previously in my previous demos? Um, so it is showing me query ID, hint ID 4, but not the history of the information. So by default, this information is not captured in the SQL Server query store views. So to get that information, history of the information, you need to enable the extended events. I have written a blog post about how to enable that, how to use the extended events to collect the history of the information of these query hints. You can see my blog post dbanuggets.com to actually see how to enable that. So now let me go ahead and use some other different hint ID. This time we are using max.1 on the query ID 3. Now we are actually thinking of using different hints, right? We are exploring the options, what we have here. So we are using the examples. Now I enable the max.1 and I will clear out my cache and I will execute these two executions again to see how it will work this time. Now, if you observe, it uses the clustered index scan. The first one, it created the clustered index scan because of 360,000 records, and the same one used because this time we are using max top 1. Now, if you see the properties here, the max top is set to 1. But we also want recompile because we don't want clustered index scan all the time. We want to use two of the hints. Now, as soon as I changed the hint, it override the existing one. It did not keep the actual one. So that is the reason we need to append instead of instead of like overriding by removing the actual uh, hint. We do not want to remove the hint, the previous hint. We want to append. So here we are using both of them currently. The query ID is 3, not 1. So we are running that. And this time we will see if both of the hints are applied. If you see here, now this time the clustered index scan as well as the index seek and key lookup is applied. Now, if you see the properties, you can see the max stop set to 1, as well as the query store statement hints. Both of them are being used. You can clearly see it here. That's how you can use the multiple query hints at the same time. Now, if you want to clear out the query hints, you can use the SP query store clear hints and use the query ID to clear out the hints. But make sure, like when you are doing this, you are losing the history, right? Clearing out. That means the hints are no longer applied as well. But if you have the extended events enabled, you can collect that information. And now, if you run this, what are enabled currently, what hints are enabled currently, you can see the results. None here, because we just cleared out the hints here, right? That's how you can use the query store hints. We never touched the actual query itself, but we used the SP query store set hints and SP query store clear hints to clear out. And for all the hints that are being currently supported, please go ahead and visit this website to see them. Now, I would like to also show you how the parameter sensitive plan optimization works and how this IQP feature can actually um, store multiple execution plans per query. So what is this PSP optimization, right? There is something known as variant plan and a dispatcher plan. Two terms that you need to remember here. In SQL Server 2022, this IQP feature, parameter sensitive plan optimization, has actually introduced these two words, variant plan and dispatcher plan. The dispatcher plan is something that will collect the logic in it, but the variant plans are, you will have up till 3 execution plans per query based upon the skew of your data. Like if you have a lot of skew in your tables, a lot of parameter values, different values. What SQL engine does is, instead of storing one execution plan in the plan cache, now in SQL Server 2022, by using the parameter sensitive plan optimization, it will store up till 3 execution plans per query based upon your parameter values. Now, why is it beneficial? It is beneficial when you have a lot of skew in your data to solve the parameter sensitive parameter sensitive issue, parameter sniffing problem. Because it saves up till 3 execution plans in the plan cache, it can go ahead, sniff the parameter, and then choose the plan based upon the parameter value. You do not have to recompile the stored procedures anymore. Now let's see how this how we can see those 3 execution plans in this particular demo. We are going to use the Stack Overflow database. We are using so we are going to set the query store operation mode read write. I will run on the Stack Overflow database, and now I'm going to set all of these options. These are the configuration options, right? I'm setting this up, and then to enable the parameter sensitive plan optimization, you can either alter database scope configuration, set parameter sensitive plan optimization on, or you can just set the compatibility level. You need the minimum requirement to enable this parameter sensitive plan optimization is to put your database in the SQL Server 2022 compatibility mode, which is 160. This is the minimum requirement that you have to do. So I'm doing that. Now my database is in the SQL Server 2022 compatibility mode. Now I'm going to just create a very simple store procedure. I'm selecting start from this table, users table, where reputation ID is reputation parameter, ordered by display name. Now I'll go ahead and recreate the store procedure, drop and recreate if it exists. And now I'll go ahead and show you how the reputation, we need to know um, the values that I'm taking here. These are parameter sensitive values, and how did I capture these values? How do I know these values? How many it produces? How many record does it produce? Is by checking the histogram value of this column reputation, because we are searching on the reputation, right? So SQL engine, when we are searching on a particular column, it will always go ahead and look into that particular column statistics to figure out how many records that it might produce, it might give back, right? So I'm going to look into the histogram of that reputation column. And if you see here, these are the column values, reputation IDs, and these are the equal number of values that we have for this particular reputation ID. Reputation ID 1 have these many records. Reputation ID 11 have these many records, and I'm ordering by the mm, ordering. I'm um, I'm doing this order by equal number of rows in the descending. So 5714 value here, where I will find it somewhere here 5714. 5714 here, it produced how many equal rows? Just 8 records here. So this one, when I execute, it will produce only 8 records for each execution. Reputation 1, we have seen here, reputation 1 have these many equal number of rows, and reputation number 13 gave should give us like how many rows? 13 should be somewhere here. 13 here. It should produce like 3794 records. Okay. Now we have 8 rows, some million rows, as well as some thousand rows, right? Now let's go ahead and execute 3 times each and enable the actual execution plan on run. Now it is running currently. And if you see, the first one we executed for 3 times, index seek and key lookup for just 8 records, 3 times is passed. And the second one we have executed 2 times. It is still executing, but it chose to do clustered index scan. Clustered index scan, if you observe, no matter the first execution after you created the store procedure, the parameter value only generated 8 records, but the next time it runs, it choose a different plan. Now, this is not something that will happen before SQL Server 2022, right? It always choose clustered index seek and key lookup because this is the one which got saved inside the plan cache. But here it is different now. It shows like a different execution plan. And then third one also shows it is using a different execution plan, which is clustered index scan. Now, if you see, they are using different execution plan, right? Now, what is in my plan cache? If I see here, if I run this, it says it shows like 3 plan handles here. And the user counts were like 3, 2, 3. If you see, we have executed 3, 2, 3. And we have 3 execution plan handles, 3 different plan handles here. If you see here, that means 3 execution plans were saved. Now, if you see, if I scroll down here, right, and if I execute this particular query, it will give me the query plan hash, the query hash itself, how many times it's executed. Do not worry about this one because this is a different query that we just executed. And how many max elapsed time, maximum number of rows, and like last DOP value, all of that, and you get the query plan itself. If you click here, it will take you to the execution plan. But now, I would like to show you something else here. The view the dispatcher and the variant information. Here, if we execute, here it shows the dispatcher plan. Do you remember the dispatcher plan is somewhere the logic is saved, where it contained the information on where to go, which execution plan to use. Now, if you scroll your mouse, you can actually show the plan in XML, but you can actually see the plan as well. I will, but then I would like to show you what is a dispatcher plan and what is a variant plan. Variant plan is the actual execution plan itself. Now, if you run the above query, this query, you will see the query variant plans, and then you will show the plan as well in the XML format. Let me close this one and let me run this particular query again to show you how the dispatcher plan will look like. The first one is dispatcher plan. This is how the dispatcher plan look like. If you hover your mouse, it says multiple plans are located in it. Based upon the parameter value that comes in, it will choose which plan it have to choose. If there is like too many records, it will go ahead and choose the clustered index scan with a lot of memory grant. If there is a medium range values, then it will go ahead and choose the key lookup index seek and the key lookup with the medium memory grant. That's how the maximum 3 number of plans will be saved, and this is only possible in SQL Server 2022. This is known as parameter sensitive plan optimization, where all you have to do is to make sure that your database is in SQL Server 2022 to make sure you enable this feature. It gets automatically enabled once you are in the SQL Server 2022 mode, compatibility mode. Let's go back to the slides. And I would like to thank you all. And I know this is a short version of my session, Query Store, but I would like to thank you for hanging in here to view this session. And I would like to wish you all a very happy New Year 2025. And thank you so much for attending. And I know I forgot my um, biodata slide, but um, yeah, I'm Deepthi Goguri, and you can find me on LinkedIn by my name, Deepthi Goguri, and you can view my blog, dbanuggets.com, where you can find the SQL Server and Azure SQL articles. Thank you so much once again. Have a happy New Year.